Hello students, my name is Narendra Singh Patel and I am here to teach you one small concept and you can say one small topic of theory of computation. So let's get started. So this is the official syllabus from GATE website of theory of computation. So these are the topics they ask questions from. So today what I'm going to discuss is context-free grammars. Okay, so let us talk about context-free grammars. So before moving to context-free grammars, let us first understand what grammars are. Okay, so where have you heard the word grammar? So when you were in a school and you were learning any language like Hindi or English, so you must have heard over there grammars. What are grammars? So grammars are actually rules, and by following those rules, we can construct any language. For example, you can see the sentence. What it is written is, "I am talking to you." So it the meaning of this sentence you can understand. Like मैं आपसे बात कर रहा हूँ. But if I say this sentence like you too I am talking, so this is wrong. Why? Because I have not used the correct rule of grammar. That is why you will get problem while understanding this sentence. So what grammar is, let me first tell you about grammar. So grammars are rules used in any language. So why are we learning grammars in computer science? Since theory of computation is a subject of computer science, why are we learning it? So in daily practices, like in normal day-to-day language, we use language, we call them as natural language. So what are natural language? So let me first tell you about natural language. So a natural language is a language that has been developed naturally over time by its users. So for example, we are right now I'm speaking in English. So English you can consider it as a natural language. But when you are programming in computer science, for example, if you are using any language, like you must have heard about C programming or Java programming language. So let me talk about C language. So if you are using C language, so C language is a formal language that has been developed by various scientists so that you can talk to computers. So how are we going to create one language? So we can create language by creating some rules, and those rules are known as grammars. So what is grammars? Grammars are rules used in any language. So it is same for Hindi as well as English as well as for computer science. So we can further modify it according to our computer science. Is like grammars is a finite set of formal rules for generating syntactically correct sentences or meaningfully correct sentences. Okay, so let me further talk you about grammar. So let me first create sentences from English language. So what is the rule of English sentence? You must have heard this rule: subject plus verb plus object, right? So I can make, by using this rule, I can make a sentence like, from subject I can create Ram, from verb I can say play, and object I can use create cricket. So Ram plays cricket. Is this a correct sentence? Yes, it is a correct sentence. Can I make another sentence? Yes. Further, I can create another new subject. For example, let me use the word Sham here. Sham. Another verb is Sham reads book, or you can say a book, not a problem. So Sham reads a book. It is another sentence. So by using this rule, you can create as many sentences as you want. So same in computer science. Same in computer science. This is how we use a grammar. This is how we use a grammar. So what it is written? So let me first tell you about the attributes. So for example, G is a grammar. So G is a grammar. We are defining a grammar by G. So G has following four attributes: VTPS. What are VTPS? So let me tell you about VTPS first. So V is considered as set of variables. Okay. So further in next slides, what I'm going to use, I'll divide. This is the grammar. Okay. First, understand it. This is the grammar. This is how we write grammar in computer science. So I am dividing this grammar into two parts. Okay. This part I will call LHS, or left hand side part, and this part I will call it as right hand side part. Okay. So all the elements which are written in capital words, they all are known as variables. So like this capital S, this capital A, and this capital B. We will treat them as variables. Why variables? Because we can replace them by right hand side part. So for example, this is this is the sentence. Yeah, this is a grammar. S is giving. Okay, this arrow is called as derivation operator. Okay, so how do we read it as? S is deriving capital AB. So let me write it here. S is deriving capital AB. Okay, students, from now on we will consider this grammar as our favorite grammar. So whenever I will give you an example of grammar, and whenever I will say favorite grammar, so you will just have to write this only. Okay. So I am writing S. So how this is read as? S is deriving AB. So now this is a capital A, and we have considered capital A as variable. So every variable can give you terminals. What are terminals? So let me see. All those small case letters or alphabets uh, are what are terminals. So S is deriving AB, and from here on you can see A is deriving a small a. So I can replace this capital A by a small a. Okay. Now let me treat capital B as it is, and from this on, and in next instruction, what I can replace capital B with a small b. Why? Because this capital B is deriving a small b. So from by using this, okay, this capital S is called as a starting symbol. So we are driving this string. So this AB is what you can call this AB as a string or a sentence. So by using this starting symbol, which is a variable, or variable is also called as non-terminal. Okay. So just write it here, non-terminal, non-terminal. Okay. Okay, let me write it. Let me write it NT, non-terminal. So by using this starting symbol, I have produced one sentence, or you can call it a string AB. So this is how we can generate sentences from given grammar. So what is a grammar? Grammar is a finite set of formal rules for generating sentences. And how do we use grammar? So grammars have four attributes, like it has variables, it has terminals. So these AB are terminals, and whatever string we will produce, our string will be in form of terminals only. Okay. And what is production? So this S deriving AB, and now I'm talking about production. Okay. So this S is deriving AB, like, or for example, A is deriving a small a. So this complete thing we will call it as production. So what is production? Capital A is deriving a small a. This is we call a production. So how many productions are there? So this is one production. Capital A is deriving AB. This is second production. Capital A is deriving a small a, and this is third production. Capital B is deriving a small b. So this is how we will use grammar, and this is a simple example of grammar. Let me proceed further. Okay, uh, so this is how we can. Let me give you another example of grammar. So this is again a grammar. What it is doing? Capital S is deriving AB as well as VC. So these are two productions. Okay, these are two productions. We can write them as capital S is giving AB, as well as capital S can also give us BC. So how many productions are there? So this is one production, this is second production, this is third production, this is fourth production, this is five, this is six, this is seven, this is eight. So a non-terminal or a variable can give any number of productions. Okay, it is according to our requirements. So can you derive any string from this grammar? Yes. How can we derive? So we can use it. Capital S is giving. Let us say we are using this time BC. Capital S is giving BC. And can we replace B by any terminals? Yes. We will go to the production of B. B is giving B or E. So let me write it a small b. Okay. C as it is. Students, this is an intermediate string. And since It does not have completely terminals. Why? Because capital C is a non-terminal here. So we will call it as sentential form. Do you remember it? I will tell you definition later. This is known as sentential form. Okay. So, and this C can be replaced by either N or M. So you can derive any string. So BM. So this is a string. This is another string you have generated from a starting symbol. So BM is what? BM is your another string. Can you derive another string? Yes, you can. Same, you can derive BN as well. And there can be multiple strings you can generate. So this is grammar. So how were you deriving strings from grammar in natural language? So this is how you were deriving. Like you were changing subjects. Like for example, Ram, Sham, and this time you can use Gita. Gita. Gita does what? Say Gita play or Gita eat. You can use eat. Gita eats. What do you want her to eat? Let us say she is eating. What is your favorite food? Samosa. Okay. So let us say Gita eats samosa. So this is another sentence you have derived. So this is how you can derive sentences from given grammars. Okay. 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 So let me introduce you one more thing. Gita eats samosa. This is a sentence. If I am using this structure or this sentence, what is it? It is a syntax. You can derive any number of sentence you want. So if I say let I'm using Gita eats Gita eats book. Okay, so is this sentence correct? Yes, according to your structure, this sentence is correct, but it is giving you a meaning or not? No, it does not have meaning because how can you eat a book? So this is not giving you a correct meaning. So, so is this sentence wrong? Yes, this sentence, the syntax of this sentence is correct, but its meaning is wrong. So how we will see or how we will check meaning? Okay, so I want you to write question mark here, and we will get back here after one or two class. Okay, so I just wanted to introduce you this thing. Okay. Okay, so let me proceed further. So so we have created sentences from another grammar as well. This is our favorite grammar. Now the major question what I want you to understand from this topic or from this session is why are we using grammar? What is the reason behind it? So students, you must have used programming, right? Okay. So how many types of sentences are there in a programming language? There are several types of sentence, right? So let me write down few things. So like there are declarative sentence. What are declarative sentence? What are declarative sentence? So you must have declare int a comma b. Is it or not? Okay. Also there are sentence like expression statement. How do you write expression statement? Like a is equal to b plus c. And there are further more types of sentences like there are flow control sentences in which you can write if else or for loop, etc. Also there are procedural calls. Also there are some input output field like printf, scanf. So what I wanted to tell you, whenever we are using any instruction or uh, any sentence in your programming language, for example I'm using simple this declarative sentence int a comma b and semicolon. So is the syntax of this sentence is correct or not? So when you will execute this instruction on your compiler, so what will be the result of this? Yes, there will be no error. Compiler will definitely say yeah, it is okay. But if you write int a semicolon b, now what will compiler do? What will compiler do? Compiler will give you an error and it will say the syntax of the sentence is not correct. So what it will give you? It will give you a syntax error. So how does compiler know that there is an error in this sentence? How does compiler know? So compiler knows this because he knows grammar. How do compiler catches it? Compiler catches it because of grammar. So how grammar helps in understanding compiler that there is a syntax error in it? So let me tell you before proceeding further, let me tell you one more thing. Okay, so let me call our favorite grammar once. This is our favorite grammar. So I just have one simple question. Okay, so before proceeding further, let me also tell you about derivation. So these all these strings what we have generated here, all these strings that we have generated are also called derivation. So we have derived our starting symbol to produce these follow strings. Okay, so if I'll say this is our favorite grammar, like as is giving AB. So my question is, can this grammar can this grammar produce okay, produce के बाद, okay, after produce, this is my first question, AB string, and my second question is AC string. Okay, so I'm just asking two questions from you. You have heard the grammar and you understood it. So can this grammar produce, first question is AB string or second question is AC string. So can this grammar produce AB string? Yes, I've seen it. So how can it derive? So you can write S is giving capital A, capital B. Then A can derive small a, and same B can derive a small b. So this is how you can generate AB string. So yes, this example is right. This example is right. It can derive AB string. But can it derive AC string? No. Because this grammar does not have the capability to produce C, hence it cannot derive AC string. Okay. So same same what my intention was to make you understand that how grammars can produce a string and how it can identify whether the string generated by, or a string you have given him a string, and how can it recognize that a string or not. So that was my intention. So I have written a grammar here and I am giving you, okay, let me first derive this grammar. Okay, or I let me give you an equation here. This is a grammar for declarative sentence. So for every type of sentence, there is a grammar in programming language. So this is a declarative grammar. So why are we studying grammar is, we are studying grammar just to understand this. So this is a grammar. Here S is deriving TD. T can derive int or float. D can derive D, I, or I can derive AB. A from A to continue to Z. So these are the following words that grammar can derive. So what I'm writing here is, I'm simply writing int A comma B semicolon. So this is my first statement, and another I am deriving. Another question is I am writing int A semicolon B. Now I want you to understand this declarative statement. When you write this statement in your C compiler program, so what your compiler does, compiler sends this sentence or this string to your compiler and ask your compiler to recognize this sentence. If this sentence is being generated from this grammar successfully, then your compiler say that this sentence is correct and there is no error in it. But if your compiler fails to generate this sentence, then it will say that this sentence is not part of my grammar, so this is not a valid sentence, hence it gives you error. So let us proceed how this grammar can generate this string. Okay, so let me just change the color of my pen. Okay, so let me write it. S can derive T comma D. Now from T, what you can say? From T you can say T can derive int. Okay, no problem. T can derive int, right? And what can D derive? What can D derive? Okay, let me. Okay, there are two ways you can use this. Either you can do it by top to bottom or bottom to up. Okay, so I'm going top to bottom. So how can you can use D as, okay, let me write D as it is and semicolon as it is. Now here you can say D can give you D comma I and semicolon as it is, and from this D you can say this D can give you I. Okay, and from this I you can say this I can give you A, this I can give you A, and your comma is as it is, and this I can give you B, and your semicolon is as it is. So if you see what sentence or what set of terminals it has produced, so you will see int, then A, then comma, then B, then semicolon. So this is the sentence this grammar has produced. So can I write it down? Yes. Int A comma B semicolon. So is this sentence or this sentence is matching or not? So yes, so compiler will say ki there is no error in this sentence, hence the syntax of this sentence is correct. I will not give you any error. But but can your grammar derive this sentence? No. Your grammar is not able to derive this sentence, or you can say, or in other words, you can say this sentence will not be recognized by this grammar. This sentence will not recognized by your grammar, hence this is not a correct sentence. That is why compiler gives you what? That is why compiler gives you a syntax error. So why are we studying grammar is we used to study or we use grammars to see whether your compiler can capture syntax error or not. So whenever you write is any statement in your C program, so all those errors are catched by your compiler by using grammar. That is why we study grammar. So in further sections, we will see further more questions of grammars, like what are derivations, how many types of derivations are there, and we will see how we can generate any language from grammar, or how we can recognize grammars by that languages. Okay. So student, it was just a small introductory topic for grammars. See you soon in next class. Thank you.